अच्छा जी, vectors lecture number 2. This is of O level vector we did in the previous lecture. We make sure we understand, we go through the vectors, knowing the fact that this was what direction, that means AB is equal to A. So if the sign of the magnitude changes is coming from the direct opposite root, so this should be what DA is equal to what minus A. Then ABC, we did AC is equal to AB plus BC, which is 2A and 3B. Then we calculated CB and BA minus 3B minus 2A. Then we worked upon the normal vectors from the different points. Considering we found out AB, BC, and AC. Then we made sure to tell you that you use any of the magnitude, you will end up having the same vector line. Then we worked upon parallelogram and the parallel vectors, knowing the fact that if the distance is same and the direction is same, then automatically the vector is going to be same. We worked upon the midpoint of the magnitude line, that if the midpoint has been given, that means magnitude will be divided into two equal parts. So today we are working on the ratio. Let's say that if this is A, let's say we have B, and let's say we have C. The direction is given already. Let's say AB is A and BC is 2A. AB is A and BC is 2A. So there are a lot of different ways where we can be tested in this. Number one, they can directly ask us vector of AC. So vector of AC will be AB plus BC, which means A plus 2A. So this is going to be 3A. So knowing the fact that it's a straight line, and we have 3 points on the straight line. So this tells me the ratio. Remember, on the same line, if 3 points, more than 2 points are taken into consideration, these are known as collinear points. These are known as your collinear point. That means if on the straight line more than 2 points are taken into consideration, that means those are collinear points. Remember, the gradient is going to be same for any of the 2 points. But again, AC will be AB plus BC, which will be A plus 2A, which is what 3A. But on the other hand, let's work upon AB is to BC. AB is to BC. That means now we are working upon the ratio, which will be A is to 2A. So A and A is cancelled. So what are we left with? 1 upon 1 is to 2. Now this 1 is to 2 means that AB is divided by BC. What does ratio means? Obviously, ratio means division as well. This can also be written in this form. That means 1 is to 2. Now, knowing the fact that this is 1 is to 2, but the total of the length will be 3. The total of the length will be, see, how do we get 3 when we add these two? 1 plus 2 becomes what? 3. So that means that if I want to find out AB, I know the ratio of AB is 1 upon 3. The ratio of AB is 1 upon 3 of the entire AC. Of the entire AC. So we can write it down this way. We already know that AC was 3A. So AB, if we just put down 3A in place of what? AC, 3 cancel, you'll end up having what? A again. Similarly, we knew that BC was what? 2 upon 3 AC. BC was 2 upon 3 AC, because the total ratio is what? 1 is to 2, which means 1 out of 3 and 2 out of 3. So knowing the fact that your AC is 3A, so 3 cancels, that means you are left with what? 2A. So it is very important to understand the ratio method, because if the ratio method is not clear, then automatically you will not be able to solve the vector lines. Like for suppose, let's say a straight line is given. Let's say this is X, this is A, and this is D. A, X, and D. I've been given that AD is, let's say 6A. AD is 6, and I've been told that AX is 2, XD is 3 is to 1. Or let's just change this, 2 is to 3. This will be more convenient because knowing that AX is a smaller line, but still, even if it's smaller and the ratio is something else, then you'll be solving against this. Now, knowing the fact that AX should be 2 upon 5, AX will be 2 upon 5 of what? AD. AX will be 2 upon 5 of what? AD. When we'll add 2 and 3, we know that 2 plus 3 becomes what? 5. So finding out AX, it would be 2 upon 5 of what? AD. So AX is 2 upon 5, and what is AD? AD is 6A. So that means the ratio to the ratio, this should be 12 upon 5A. So that means we can directly write down this as 12 upon 5A. Similarly, we can also find XD, and the XD will be 3 upon 5 of what? Of entire AD. 3 upon 5 of the entire AD. Because your AD is a complete line and we are taking out ratio because of that. So XD will be 3 upon 5, and we know AD is 6A. So XD is equal to what? 18 upon 5A. So let's just take this in the consideration, knowing the fact that let's say AD is basically AX plus XD. Now this is 18 upon 5A. So XD AX is 12 upon 5A plus 18 upon 5A. So when the denominators are same, we just add the numerator. So 12 plus 18 is 30 upon 5A. So now you end up having the same magnitude, the same vector line, that is 6A. And we had this in the start. And we actually found out the ratio of this. Let's work down with the example question. Now see, the question is pretty much clear in the diagram. ABCD is parallelogram. What does parallelogram mean? That means if AB is 6P, then automatically DC will be 6P. If AD is 8Q, then automatically BC will be 8Q as well. And the same direction will be used as because of the parallelogram. X is the point on BC. We can see that X is the point on BC. Here's the point. Such that BX and XC is 3 is to 1. Find out BX. So remember this, that BX is 3 and this is 1. BX is 3 and XC is 1. So 3 plus 1 is basically 4. 3 plus 1 is basically 4. So if I want to find out BX, I will do 3 upon 4. I will do 3 upon 4 of the entire line BC. And the entire line BC is 8Q. So BX is equal to 3 upon 4 of what? 8Q. 8 ones are 8 twos are, that means we end up having what? 6Q. So BX vector is 6q. So if this is 6q, then automatically this will be what? 2q. This will be 2q. Express ax in terms of b. Now the question continues. We need to find ax. To find ax, what we'll do is we'll make a root. We'll make a root. To go to ax, we'll go to ab. Then we'll go to bx. We'll go to AB and then we'll go to BX. And now we already know the vector. 6P is for AB and for BX we already know it is 6Q. So AX vector line magnitude is 6P plus 6Q. And this is 1 mark question. 1 mark for the ratio, 1 mark for the normal vector line. Now normally the question comes through the ratio when the examiner would test you for the line magnitude. If the question examiner wants you to divide the line into two different parts, they'll always divide it through the ratio. So this technique of ratio is very important because normally in all the questions this is being tested. If you do not try to understand the ratio method and you do not give attention to this, then you will not be able to do the vector question because in each question or almost after each 1 or 2 questions, you will end up having the ratio question in the topical past papers. And eventually the examiner will also test it through the ratio technique. So you need to understand the ratio very well. Now let's work on the position vectors. Now generally position vectors, let's say I want to find AB. I want to find AB. So what I do is I'll do OB minus OA. Now this is generating the magnitude root directly. If it is CD, position will be from origin, so it will be OD minus OC. The second one comes first, the first one comes later. If it is XY, this should be OY minus OX. If it is WV, so it will be OV minus OW. So this method is generally used when the diagram is not given. But let's just work upon the concept of this. Let's say I have been X and I have been given Y. This is your A and say this is your B. So from the origin, there is a line that gives the root of OA. And there's a line that gives the root of what? OB. Now, remember this, that A is a different coordinate and B is a different coordinate. Let's say this is 2 and 10. Let's say this is 8 and 4. One is 2, 10, the other one is 8 and 4. Just a random. But what does this 2 and 8 shows? This 2 and 8 basically shows change in X is 2 and change in Y is 10. This B shows change in X is 8 and change in Y is 4. This change in X is 8 and change in Y is 4. For this, change in X is 2 and Y is 10. So for each, there is a change for each coordinate. But you have been told to find AB now. You have been told to find what? AB. Now generally, these two lines are not there. Let's say these two lines are not there. So that means we are just working down with coordinates. So how we are going to link these coordinates with each other? Now these two coordinates has to be linked to each other. You can't find AB directly. So what you're gonna do is you link it with origin. As I said, we'll draw the line from the origin to the point of A. We'll draw the line from the origin to the point of A. Obviously, coming from origin, the direction will be like this. We draw the line from origin to the point of B, and obviously the direction will be like this. So, if I want to find AB, What I'll do is I'll go to AO plus I'll go to OB. I'll go to AO plus I'll go to OB. So what does AO means? Since I'm coming from the opposite direction. Since I'm coming from the opposite direction. So this is going to be what? Negative AO plus OB. So AB is basically OB minus AO. So you can eventually write this as what? OB minus OA. Why? Because if you look at this AO gives me negative magnitude because I'm coming from the opposite direction. But when I'm writing down, you need to understand this. When I'm writing down OA, let's say I'm writing down 2A, but I need to show it in the negative direction. So I'll do what? Negative OA. So negative what? OA, because I want to show the negative direction. When I want to show the negative direction, this will be opposite. So this will be negative OA. That is where the formula that comes in. The formula arises from here. Your formula comes through what? AB is equal to OB minus what? OA. Now, your AO is generally the normal magnitude that will gonna come. So that means either I'm going to write this, or I can write this or this. Now, working on with this, what we need to understand is that these two coordinates are very different from each other. These two coordinates are different from each other. So we need to work accordingly to that. Let's say that we have A as 2 and 10. So OA will be 2 and 10 in the matrices form, in the column vector form. Column vector form is X and Y. What does it show? Change in X, and it shows change in Y. It shows change in X and it shows change in Y. So that means my 210 can easily be written in this column vector form which is 2 and 10. This is coordinate of A, but this shows the vector of OA. Now, your B is 8, 4. This is your coordinate 8, 4. But OB will be the vector 8, 4. And vector shows change in X and change in Y. Change in X and change in Y. So if you want to find AB, if you want to find AB, so what is AB? OB minus OA, which means 8 and 4 minus OA is 2 and 10, which is going to be 6. 8 minus 2 is 6 and 4 minus 10 will be minus 6. So that means column vector of AB is 6 minus 6. Change in X, change in Y. Now, you have already done transformation, so you understand that change in Y is downwards. Change in X is on the right. Because this is positive, this is negative. So positive and negative. Change in X is positive 6, this is negative 6. From right to left. So that means this creates what? A line. Let's say this is creating a line of AB. But this line of AB is basically giving me what? Change in X and change in Y. Change in X and change in Y. Your change in Y is minus 6. Your change in X is what? 6. And this came along from where? From change of A. From change of A. And this came along from where? Change of B. When we subtracted your A and B with respect to OB minus OA. Now, how does this help us? This helps us because generally the question tells me to find out AB magnitude. This is magnitude. And magnitude formula is under root x square plus y square. Under root x square plus, this is basically Pythagoras theorem. When we are linking this becomes 90 degree, this becomes 90 degree. So, generally when we have x as what? AB was 6 and minus 6. So, this becomes what? 6 square plus negative 6. So, this is 36 plus 36, which is under root 72. So, the magnitude of AB becomes what? Under root 72. Now, this type of magnitude only when the coordinates are given to us. When the coordinates are given to us. Let's just work upon random. The question can be 2, 4, 4 and 10. Let's just do this way, right? And I've been told directly to find AB magnitude. Now, this is your question. You have been given coordinate A, you have been given coordinate B, and you have been told to find out what? Magnitude of AB. Now, with that, you need to find actually AB first, which you do not have. But you know that OA will be 2, 4, and OB will be what? 4 and 10. So, AB is basically OB minus OA. 4 and 10 minus 2 and 4. 4 minus 2 becomes 2, 10 minus 4 becomes what? 6. So now you know that AB is what? 2 and 4. So magnitude of AB will be under root 2 square plus 6 square, which is 4 plus 36. Under root what? 40. So under root 40 will be the magnitude of A, B. So generally the question with the position vector comes through the magnitude and the normal vector where we'll be using under root x square plus y square. Let's work up with the example question of the matrices that can be tested as well. So m minus 2, n is already given. So there should be 3 minus 2, minus 2, and n is minus 1 and 4. So 3 minus 2 stays same, negative stays same, 2 will be multiplied, minus 2 and 8. So this is going to be 3 plus 2, negative, negative, positive, and minus 2 minus 8. So this is going to be 5 and minus 10. So the first is 5 and minus 10. The other will be SM. So S 3 minus 2 is M plus 3N minus 1 and 4 is equal to 12T. So this is 3S minus 2S, and this is going to be minus 3 and 12, right? These are the two brackets and 12T. So if you just see that in the first part, in the first equation, because there are two equations, you have 3S minus 3 is equal to 12, which will give me the value of S only. Plus 3. So 15 upon 3 becomes what? 5. Then in the second equation, if you just see that we have minus 2S plus 12 is equal to what? T. Right? So this is going to be minus 2, 5 plus 12 is equal to T. So T becomes minus 10, minus 10, 2. So 2 and 5 will be the answer for the matrices question, but this is normally tested through the vector question. That means that might be included in the vector or this might be included in the matrices topic. Both can come along, but obviously matrices will not be part of the syllabus from next year, so still it will be tested in the vector topic.